Okay, up next we have NuCypher. David. There you are.
Hi.
Can you see me okay?
Yes.
Can you hear me okay?
Yes, perfectly.
Perfect.
So,
Well, I can see and hear you perfectly too. So you ready to tell us what's going on with managing our dApp secrets with privacy on chain?
yeah.
All right,
So,
cool. Take it away.
thank you very much for giving me the opportunity to talk in this great conference. Let me share my screen. Okay. Okay. So the topic of this presentation is to talk about NuCypher. Probably you have already heard about NuCypher previously, but I will anyway give you a brief idea of what it's about. Basically, NuCypher is a platform for managing secrets in decentralized applications, and it allows you to share information that you have previously encrypted and share it in a secure and scalable way using our decentralized network of nodes. So first, just tell us about, just tell you something about NuCypher. The vision that motivates our work is that we believe in conditional privacy as a fundamental right of people. We think privacy is extremely important to create ideas, to collaborate, and essentially to empower individuals to assert um, their fundamental rights in this digital age. From that vision, we created technology that enables to we created a network or an infrastructure that enables the provision of a cryptographic service that powers privacy preserving applications. And in the application of the blockchain space, NuCypher can be used as a data privacy layer for decentralized applications, and that gives the functionality basically of secrets management and dynamic access control. So, how do you use NuCypher? You have created a decentralized application. It's great. It works perfectly. But now you have the problem that maybe your application the users of your application has some data that needs to be shared, and you want to give the users privacy and security for that data. But at the same time, you want to share it. You want users to be able to share information with others. So how can you do this in an scalable and trustless way? So the first approach that anyone can think is, okay, let's use encryption, and in particular, let's use, for example, public key encryption. And this can, of course, work, but it will have several limitations because initially, let's assume that you have data that it's in control from Alice, and Alice wants to share data with Bob. Okay, once Alice knows Bob public key, she can just encrypt it and distribute it. But what happens if now we have a new data consumer called Charlie? Now Alice would have to take all her data again and encrypt it again for Charlie. And what if there are 10 more users or 100 more users wanting this data? So this solution doesn't scale at all. Another problem is what if the other problem is that then this implies that Alice has to be online for making this process of encrypting the information and with the different recipients, which is of course very inconvenient. What if we assume that Alice trusts a remote service. Of course, we all know that this is something that is an assumption that we cannot do. There are many potential threats out there that completely disallow this option from being considered. So, okay, what can we do? This is where our magic comes to the rescue. This is a cryptographic primitive called Proxy Encryption. It's been out there for more than 20 years, I'd say, but it's been only from a couple of years since it's been really taken into consideration more deeply. And it essentially works very similar to public key encryption, but it has an extremely interesting property, which basically allows Alice to take to create a special kind of cryptographic key called the encryption key. And with this key, she can give this key to some intermediate entity, which usually they call it the proxy. And the proxy is capable now of transforming any ciphertext that was encrypted for Alice and transform it in a ciphertext that Bob can decrypt. Sorry. So the problem that I mentioned before about scale, the lack of scaling of public key encryption, now it changes completely here, because now if you want to share data with Charlie, then Alice only has to create a new encryption key and give that key to the proxy. Then all previously encrypted data that was encrypted under Alice's public key, the proxy can transform it for Charlie. And this process can be repeated for any number of recipients. The cool thing is that the proxy cannot access any data. And the encryption key doesn't give the proxy any kind of advanced ability over the ciphertext or over the underlying encryption, or not. It's not capable of getting the private key of Alice. So basically, Alice is only giving the proxy the possibility of transforming data from her key to a key that an authorized recipient can decrypt. Okay, so that was the like the overall explanation of how a generic proxy encryption scheme works. But in our setting, in the NuCypher network, we developed a crypto system called Umbral, which is a threshold proxy encryption scheme. The name Umbral comes from Spanish. Umbral means, you guess it, it means threshold. So essentially, the Umbral crypto system allows you to distribute what we previously represent here with just one key, the encryption key for between Alice and Bob, for example, and distributed to several proxies. So the cool thing is that this is in a threshold way. So you have M of n. It's an M of n threshold, so you can distribute it, for example, between 5 shares and set a threshold of 3, for example. So as long as 3 proxies participate in the process, the receiver can get the data. And another of the cool things is that you have a non-interactive zero-knowledge proof for correctness for encryption. So proxies cannot cheat during this process, and they can be you can detect if they are not producing the correct encryption. Okay, so the NuCypher network. The NuCypher network provides runtimes and interfaces for managing secrets and access control in a decentralized, permissionless, and censorship way. it's extensible, so it can be extended to other cryptographic primitives. Proxy encryption is our first offering, but we can extend it to other primitives. And we created in such a way that to make it intuitive to explain, and we extend the classic narrative of Alice and Bob with other characters. So the characters that we use are the typical in cryptography, the Alice and Bob. So we have a data owner and the recipient. But we add two more characters. One is the Enrico, which is the entity that encrypts the data on behalf of Alice. The encryptor doesn't have any data sharing capabilities. The Enrico, the encryptor, only produces encrypted data. And the other character, which is the core character in the NuCypher network, is Ursula, which is the proxies or the nodes that form the network and that provide the encryption service. Right, okay, I already said that. So how does it work overall? So essentially we will have the same kind of setting that I commented before, but in this case, we also have, instead of one single proxy, we have a network of proxies, which is the NuCypher network, and this is interrelated to the Ethereum blockchain. Policies for data sharing are managed in the blockchain, and they're paid for in ETH in Ethereum, and NuCypher nodes will get fees and also token rewards for their work. So I will explain a bit of how this works with an example. So imagine we have this use case where Alice has a heart rate monitor that monitors her heartbeat, and she wants to encrypt this data and have it in some storage. And at some moment later in time, she wants to share this data with a doctor. So with NuCypher, she will create a policy granting access to her doctor and send this policy to the NuCypher network. And then at this moment, the doctor can just simply take the encrypted data from the shared storage layer and request a encryption from the NuCypher network. The NuCypher network will perform a distributed computation, and Bob can now decrypt the data with his own private key. So why NuCypher is unique? Basically, the whole point of NuCypher is that in this case, the user Alicia can create public keys before knowing the potential consumers, and this enables a lot of great advantages. So, for example, anyone that knows the policy public key, for example, a heart monitor or whatever device or other users, they can produce encrypted data that will be associated to the policy, and this can happen before granting access to Bob or to any other consumer. So basically, data producers are completely unaware of the recipients. And if there's one takeaway message that I would like you to have from this talk, is that is basically that the encryption is decoupled from data sharing decisions. That's what it's unique about proxy encryption. And there are other characteristics. For example, Alice never interacts with the doctor. She only needs to have his public keys. She only interacts with the NuCypher network when granting access to the doctor. And after this, she can just disappear. And the doctor will never interact with Alice or the heart monitor. The doctor only needs to be able to read ciphertext and interact with the NuCypher network. Okay, so that was the explanation of how it works. And we are live. We are live since October 15 from last year. we started with a token distribution mechanism called the Warlock, where a user had to stake to run a node. We had over 2,000 participants and almost 350K ETH stake for this period of time. We believe that this was an awesome response. And okay, so it's demo time. So we have, I'm going to first show how the first step will be to get the public keys of Bob. So Alice can use these public keys to grant access to him. Okay, so at this moment I'm just running our CLI commands to get I already have an initialized Bob character in my computer, and I'm just asking for the keys. Okay, now I have the keys. Now I can use our Enrico character, which is the encryptor, to so with this command, we are basically encrypting some message associated to some public key, and we are storing this ciphertext directly on IPFS. I previously created, to make it this shorter, I previously created a policy encryption key, which is what I'm going to use here. Okay, so this is the message that I want to encrypt, and it's encrypted with this public key. This public key is associated with it can be associated later with a sharing policy. And this is what I'm going to show now. So now this command is what gives Alice the possibility to share data with Bob. Okay, so what we want to do is we will specify a data sharing policy specific to Bob. This is why I asked for Bob's public keys before, and we will create the policy for a certain duration of time, and we can also customize the policy with some other parameters I will show you. Okay, so this is the policy encrypting key. This is the policy verifying key, and this is the data label. The data label is like a sort of category that we use for associating the policy encryption key. Okay, I can see very well. Okay, we will create the policy for a number of days, and this, for example, allows us to create so the encryption key be split in several shares. In this case, it asks us for a default of 3 shares, which we'll say yes, and a threshold of 2 is fine. And this is regarding the payment of the policy. Okay. So now what this will do is this will create a policy in the Ethereum network. In this case, this is going into our testnet links, but the process will work the same for Ethereum mainnet. And after just some time, while the transaction is mined, we will see the policy created. Okay, we have some other information, but essentially what's important is that we know now that the policy was created, successfully created in the NuCypher network. And now we can just we can just let me copy this. NuCypher Bob retrieve. So this is the last part of the demo where Bob retrieves a ciphertext that we created before with the Enrico character. And in this case, if you remember, the command stores the ciphertext automatically in IPFS. So I am going to retrieve the CID of this data, and it will communicate automatically to that, and it will retrieve the ciphertext. Now I just need some of the policy metadata. Yeah. And now at this point, what this did is the NuCypher application took the ciphertext and sent it to 3 different nodes in the network. And at the moment where 2 of them responded with Argo encryption, it was able to combine these encryptions and decrypt it locally with Bob's private key. And we have the ciphertext correctly decrypted. Okay, so I expect that this was clarifying regarding how the command line works for NuCypher. There are other ways to interact with NuCypher. We have a Python API, and we have also JSON RPC endpoints. So in ETHDenver 2021, we have a bounty. We had several bounties, in fact. So we have $3,000 for the most interesting use of NuCypher Network. It's splittable between teams, so don't be shy and try the bounties. We have also $1,000 for the best integration of NuCypher with Textile for content distribution, and also a total of $1,000 for memes and art that represents the NuCypher community effort. You have there all the information needed. And so we have also, there are many interesting ideas that would be great to have. For example, it would be great to have apps that provide help to marginalized and underrepresented communities, for example. Also, in-game end-to-end secrets, encrypted video streams, whistleblower applications that deliver encrypted tips to journalists, content subscription platforms, which you can think about encrypted OnlyFans, for example, stuff like that, or stuff like the example I mentioned about data sharing of data collected by wearable devices or IoT devices. And what's next for NuCypher? So we have several challenges ahead. We have the problem of scaling. I think we are all aware of how difficult it is being the situation regarding fees. So NuCypher relies on Ethereum transactions for several things, like, for example, creating policies to perform stake operations. NuCypher nodes have to perform a daily check-in, for example. All these operations require an Ethereum transaction, and the gas prices are just crazy. So now, there are different things that we could do, but potentially layer 2 is the best road ahead. So that's something that we are working on right now. A JavaScript library to interact with NuCypher. So currently, as I mentioned, we only have Python and JSON RPC interfaces, and it would be great to have something to interact from the browser directly. And we are working on a Rust backend so to make that possible. And regard to the cryptographic services offered by the network, we currently have proxy encryption, but this can be extended for threshold signatures or distributed key generation, and all potentially other cryptographic protocols. And that's it. I hope that this was interesting for you. We have several bounties, and we would love for you hackers to get your hands on NuCypher. And we are constantly on Discord, so please come and talk to us. If you need to have, if you need help for setting up your dApp to integrate it with NuCypher, just let us know. There is some links also for documentation. And yeah, I hope this was interesting and clarifying for you. I guess that will be time for questions.
Yeah, it looks like we have a couple, David. Let me see if I can pull some up here. You take a look on the right in the comments.
Okay. Okay. Is there a way to tell an Ursula to check on-chain state? I guess you mean like for encryption, like for make some sort of conditional encryption. If that's the case, I mean, that's something that we would be very interested to do, and it's currently not possible, but it's something that it makes a lot of sense, and it will greatly improve the functionality of the network, because essentially it will allow for conditional encryption. Yes, we will share the slides. We will publish them as soon as possible. I don't understand the question regarding API usage of NuCypher, but as I said, we have our Python API and our JSON RPC API, and we plan to extend it so it can be easily interoperable from the browser too. Okay, and I don't think there are more questions. Yeah, conditional encryption will be game changing, definitely. We have that open as one of the most important open issues right now. So yeah, it would be great to do that. And okay, so I think that's it from my side. If you have any more questions, please come to our Discord, and I think you will find it very interesting to hack on NuCypher. I hope you enjoyed the presentation.
Thanks, David. We really appreciate it, man. Thanks for the update on everything.